Okay, so guys, we're getting started. And Peter, can you lower your laptop, please? Yeah, you guys know your laptop's open. All right. So 833. Use geometric relationships in the diagrams below to solve for x. A is pretty straightforward. You should know if a 2 degrees is the top angle, and you got two congruent sides, and you have two congruent angles. So the remaining degrees have to be split in half. If you have 82, then 98 is what's left over. Split in half, you get 49. So that should be pretty straightforward. And for B, same thing, but this time the angle given to you is one of the congruent angles or the base angle. So that means the other angle is also 71. And then, of course, do 1A minus the sum of 71 plus 71, which is 142. 1A minus 42 is 38. So that should be pretty straightforward. Old school stuff, like just make sure you know how to prove triangles are congruent. Clearly, you have an angle in between and you have sides. However, we're not doing congruence. My apologies. It's similarity. There's no such thing as hypotenuse leg similarity, so that's just crazy. And you have an angle in between two sides, so side angle side similarity. So hopefully that was recognizable. Okay, and then finally for homework 15. Um, oh wow, that's powerful. All right. For this one here, questions on any of these at all about the this homework on homework 15? No? Pretty straightforward. By the way, 838 was very similar to the notes. Actually, that exact problem was in the notes. So I think I specified like you didn't have to do it. Lecture notes. Here we go. Let's see. Yeah, because 838 was actually assigned right there. So, and by the way, Mr. Davidson, he oh sorry, that's what I meant. Wait, where do you leave things off, you guys? 836. Okay, so you guys did 836? Okay, so I'll pick it up from there. Okay, got it. Yeah. Yeah, right here. Just come up and grab one. Yeah. Did you lose it or? Okay, so let's just take the whole thing. It's fine. Actually, let me do what you need. Yeah, you don't need the whole thing. Um, okay, so coming back to this again. Yeah, so I think one of the problems was not necessary. That was look at the homework again. Homework 15. Again, homework 16 is gonna be delta math. But yeah, 836 is already done in notes, so there you go. Okay, so we have that all squared away. Um, other questions about the homework at all? About 842 or 843 or 844? No? Girls, we're good in the back? We're good? Okay. All right, then let's move on to the notes. All right, so if you guys get your notes packet out, let's do a little bit of notes. Yeah, today's. And then yeah, I don't see you guys tomorrow, so the sophomores are not impacted because you guys have the retreat tomorrow. So we're okay there. Yeah, where's the retreat? Where are you guys going? Okay, cool. All right, so let's finish off the notes. Okay, and actually, the more I think about it, I think these were assigned the homework, weren't they? Yeah. So let's just talk about it really quickly. I mean, this will be fast. I'll just do it with you guys. This will be really quick. Yeah, because that's kind of crazy because that is the notes. So the notes is the homework. So, but we'll just do it again. It's fine. We'll just not knock it out fast, and you guys can work on the little project today. All right. So 837. Suppose a regular polygon has an interior angle measuring 120 degrees. Find the number of sides using two different strategies. Show all your work. So here are the two strategies you can use, and this was actually part of the homework. You could do this. You could do find the exterior angle. What's the exterior angle going to be?
Oh, oops.
Yeah, because you got to do 180 minus, right? So then you do 360 divided by 60, which would be 6 sides. So that's one approach. The other approach you can do is you could do n minus 2 times 180, which is the sum of all the angles in a polygon, interior angles, mind you, divided by n, the number of sides or angles, equals 120. I think the second method is a little more complex. Personally, I'd find the exterior angle, which is supplementary to the interior angle, and then divide 360 over that. That'd be easier. And by the way, this formula, people have been asking my E-period yesterday, well, do I have to memorize that? Well, yeah, but if you think about it, just to help you remember, you don't have to write this down, but just to help you remember, when you have 3 sides, what do all the angles add up to again? If you have 4 sides, what do you add up to? Yeah, because you guys spend so much time with that, right? So you guys are very comfortable and familiar with that. And then we notice that there's a pattern that keeps going by 180, right? And it's a linear function, right? Because it's going consistent, right? There's a consistent difference with y and x, or some could be y and could be x, right? You could think of like this is x and this is y. So then if I go backwards, I mean, you don't have 2 sides, it's dumb, but if you have 2 sides, you go backwards, that'd be 0 degrees, right? If you have 1, that'd be negative 180 degrees. If you have 0, that'd be negative 360. So what I'm doing is I'm turning this into a linear function. Y equals 180x minus 360. And what if I factor out 180? What do I get? X minus 2. That's where that formula comes from. It comes from the fact that you're treating the angles of a polygon as a linear function. So hopefully you never forget it, okay? You shouldn't have to memorize it. You just understand that's a linear function. That's all you ever have to do. Now, if I solve it, it's not hard. That's 180n minus 360 equals 120n. And then move things around. 60n equals 360, n is 6. So those are 2 ways you can do it. Doesn't matter to me which approach you take. Whatever you're comfortable with is good for me. So now, if you look at 838, how many sides these polygons have if the sum is 1980 or 900 or whatever, right? So if the sum is 1980, I'm going to set that equal to n minus 2 times 180, which should be 11 equals n minus 2. So what does n equal?
Wait, it wouldn't be 11.
13.
Yeah.
13, good. Or if I do 900 equals n minus 2 times 180, 5 equals n minus 2, and of course equals 7. So those are pretty straightforward. Just set them equal to the formula, work it out. And as you do use this form over and over again, I think it'll just stick. If you know you still have a hard time understanding the linear stuff, but the linear stuff's pretty easy to understand. But anyway, it will stick. And then if the exterior angle is 90, well, you see 360 over 90, that's easy. You get 4. And if it's 4 side, what do we call that? It could be a square. But to be on the safe side, call it quadrilateral, because we don't know if it's a square. Actually, you're right. It is a square. I lied. Yes, because it's regular. You're right. It is a square. Or it's a quadgon, if you want to call it that. So anyhow, okay. And then if we look at CDE, then we could work on a little project today. Ooh, these are good. Okay, so these involve a little algebra, right? Each interior angle of a regular pentagon is 2x plus 4. what is x? So again, you have 5 sides. So I'm going to take the approach of the exterior angles. If you do this in a, by the way, you'll get a calculator. That's 72. That's each exterior angle, right? Maggie, can you leave Reagan alone? Thanks. Okay. So the interior angle has to be 108. So if that's true, right? So how do I find exterior angles? Because all exterior angles out to what again? 3. So it's like a full circle. It's kind of like you're going around. It's a full circle. That's really what's happening. Divided by 5, because you got 5 sides, is penta. Penta's 5. So the interior angle is 108. And if you want to solve for x, you set 2x plus 4 equal to 108. 2x equals 104. X is 52. And then for the measure of the 4 extra angles of a pentagon or that, the remaining, well, these have to have to 360, right? So 57 plus 74 plus 56 plus 66 plus x equals 360. And if I clean it up, I should get 130 plus 123 so 253 plus x equals 360. X has to be 107, I think, if I'm not mistaken. Yeah, that makes sense. And then lastly, find the sum of the interior angles. Doesn't matter if it's regular or not. No, it does not matter. Because you're trying to find the sum, not the measure of each. So that's easy. 11 minus 2 times 180. 9 times 180, which I think is 1720 or 1620. Yeah. 1,620 degrees. Okay. So this is perfect. We have 8 people. Superior work with Sabine. And then, of course, Greg and Maggie. I know you'll work together, and the girls will pair up back there. So I'm gonna have you guys work on this thing here. I wish I actually scanned this, and let me see if Mr. Davidson has a copy of it in Google Drive. If not, then we'll have to let me freeze that for a moment. Give me a sec here. Google Drive. Okay, spring 2026 or unit 3 and outs. Cool, I found it. All right. So let me show it's up here. Let me down this as a PDF. Awesome. Okay. All right. So I'm going to hand this. So you and your partner will have the same exact ones. Just so you have here at home.
How much is this graded?
You could grade if you want to.
Yeah, like, and put it in?
I think it depends.
Sure.
I'm sorry,
Yeah. Yeah, we like talking about.
All right. So before you get too carried away, Let me do one of these with you guys. I'll do the one that's like the 9 sides. Yeah, I'll do that one. Okay. One. Okay, I'm gonna do this one here. Oh, I'm frozen. Here we go. Okay. Okay, so here's the deal. What you're gonna do is you're going to figure out everything about the shape and name it. So in this case, how many sides I got? 1, 2, 3, 4, 5, 6, 7, 8, 9. So we call it nonagon, or you call it 9gon if you want to do that. Okay, the total sum of the interior angles. Well, I know my formula is n minus 2 times 180. So I need to work that out. The measure of each interior angle, I'm going to do n minus 2 times 180. I'll put a giant bracket here, all over n. The exterior angle is always is 360. The measure of each exterior angle is 360 over n. And then this is the new stuff that you're going to do. And I mean, I could go through the calculations. I mean, you know what to do. That's going to be 7 times 180, which I think is what? 700, that's 1260. Then I got to do 1260 divided by 9, which, I need a calculator for that one. Not the my head. 1260 divided by 9, which is going to be 140. My extra angle, of course, is 360. But the formulas will be the same for everybody. Then divide by 9, that's 40 degrees for each exterior angle. So those should be pretty straightforward. You guys have done this many times now, right? The part that's going to be new is in the bottom of the sheet. It says draw one triangle from the center of your shape to 2 adjacent vertices. The measure of the central or apex angle of each of the triangles and the measure of the base. So what you're going to do is you're going to draw a center and draw a triangle like this. And ask yourself, I'll call this like A. I'll call this B and B. How do I know those two bottom ones are the same? How do I know that? Isosceles, yeah. Well, it's regular, of course, but just for this triangle specifically, because it's coming from the same place, right? And it's going to these two vertices. So we expect it to be isosceles. Now, how do I figure out A is?
360 divided by the other.
Correct, right. Because I go around the circle once. So A is going to be 360 over 9, which is 40. And then B plus B has to be 140. Or 2B equals 140. So B is 70 degrees. And these things will matter when we meet again on Thursday, where we have to start finding area of these. Because what's going to happen, as you could probably imagine, what we're going to work towards on Thursday is we're going to use trigonometry. You guys remember SOHCAHTOA, right? And we're going to draw the altitude, and we're going to use trigonometry. We're going to make right triangles, and we're going to use trigonometry to find the length of the height and the base. And if I have that, how do you find area of a triangle? That's 1/2 times height. And I have how many triangles I got here? So I do 9 times the area, and now I get the area. So we're going to start deriving the formula for area of these shapes eventually. This is where this unit is very, very computative, not so much proofs. In fact, actually, I think we have 0 proofs in this unit. But it's heavy in the calculations. You're going to see heavy, heavy calculations on Thursday. So that's what we're going to do. But we got to prime ourselves for that. So what you're going to do right now, you and your partner, whatever shape you got, do it, work it out. Then what I want you guys to do is just to talk about the class. So you have someone come up, and I'll project the shape, and you'll write on the board, and you're actually going to teach us the stuff. Okay, we're gonna learn from each other. So we'll spend a few minutes. Shouldn't take too long. Then we'll have every group present. After that, you guys can do delta math. So
Wait, yeah. On the answer based on each of the formulas here.
correct. Right.
So this one is 540.